Okay, so guys, today's going to be a review. We're going to review, this is static electricity, lightning, and magnetic electromagnets, okay? So for your homework, you're supposed to list the materials you would need to make an electromagnet. Puppy, what materials did you write down? What materials would you need to make an electromagnet?
I need a battery, a nail, and wires.
And wire, very good. What would you test? What would you use to test your magnet? Your electromagnet.
I test if the paper clip stick to the wire.
And how would you know how strong your magnet is, Puppy? How would you know how strong your magnet is?
I would test.
Yeah, would you count how many paper clips it picked up?
Yes.
Yeah. Cool. Thank you for sharing, Puppy. Kim, what did you write down? Kim, what did you write down for homework?
I write down.
Guys, make sure your homework is out and ready. Make sure your homework is out and ready. I'm going to call on a few of you.
I need a battery, a nail, a couple wires, and a paper clip.
Okay, and how are you going to test your electromagnet after you make it, Kim? How are you going to test the strength of it?
I test if the distance between the object is far, but when the magnet can attract the object, so that magnet is strong.
Oh, that's awesome. I like how you're going to test it. You're going to test the distance it's able to pull an object. Very cool. She's going to measure how big the electrical field is, the electric field. Okay, Rose, what did you write? Rose, what did you write?
So we need a nail, a battery, and a string. When the string connects to the battery is stitched. When it's out, it's off.
Very good. And the string, I would switch the word for string. It's called a wire. A wire. W-I-R-E. W-I-R-E. I'll write it on the board. But that was a great, I like what you're going to do, but it is a wire. You need a wire. String will not work. String will not work. But a wire would. Let me make it a little bit bigger. So wire. It is the pink word on the board. The pink word on the board. Wire. W-I-R-E. Thank you for sharing, Rose. Okay, Blue Moon, what did you write for homework?
Is nail, wire, magnet.
Okay, and how are you going to test your electromagnet?
It's quickly.
How are you going to test how strong the electromagnet is?
It's quickly.
It's quickly. What did you write down?
The electromagnet attract impact to the area is quickly.
Okay. Taylor, what did you write down for your homework?
Use batteries, a nail, and wires.
Okay. And how are you going to test the strength of your magnet?
I will place the paper clip far away and see if the wires can pull the paper clip.
Very cool. How how many paper clips do you think your electromagnet would be able to pick up? If you had a guess, how many paper clips do you think it would be able to pick up?
I think 3.
3. That's a good guess. Milk, what did you write?
I write is
What materials would you need to make an electromagnet?
yeah. Let me find. I don't know.
You don't know? Okay, so Milk, if you can't find it, it's okay. If you still need to write it down, I would check out page 121. 121 has a list of the materials.
But I can't.
You can't find it? It's okay. If you can't find it, it's okay.
I find it.
Okay. What did you write?
First I get a battery and iron rope, a nail, paper clips, cut iron rope for the iron rope attached to side battery. For the nail, attach the rope, turn on the battery, then it taps the paper clips.
Very good. And how are you going to test the strength of it? How are you going to test the strength?
Strength.
The strength, how strong it is. How are you going to calculate? How are you going to test the strength of your magnet? What are you going to look for? Or what are you going to test? Are you going to count how many paper clips it can pick up? Are you going to check how the distance the magnet works? There's different ways, but what would you do? How would you test your electromagnet? How would you measure the strength of it? How strong the magnet was that you made? You don't know?
I didn't know you are talking.
Okay. So, guys, I just want to let you know before we move on, if you ever decide to make an electromagnet at home, make sure to do it with your parents and make sure to use insulated wire. Make sure to use insulated wire. Okay. So I'm gonna show you a picture. If you guys want to do this safely at home, make sure to have your parents' permission and make sure to use something called insulated wire. Insulated wire is wire that has like rubber around it. Wire that has rubber around it, like this. Now, I would highly recommend not making this at home. It can be dangerous. You're using electricity, batteries, wires, and it could be fun, but just be prepared. You might get shocked. It can cause fires. So just be careful. Be very careful. Make sure to be with a parent and realize that you might get hurt or shocked. It's part of the making things. It can happen. It can happen. So if you guys decide to make one, make sure to try to use insulated wire. But it's not part of class. You will never be asked to make an electromagnet. Mr. Connor decided it's a little bit too hard to do at home. But just to let you guys know, make sure you have your parents with you, and just realize you could get shocked and stuff if you're trying to build an electromagnet. Okay, it just comes with the territory of building an electromagnet. So you guys just be safe. I don't want anyone to start any fires or anything at home. So please make sure you only do this if your parents are home and are helping you, and you guys maybe research on how to do it properly. There is a section in your book that tells you how to build an electromagnet on page 121. So just make sure you follow those directions with a parent, but that's only if you want to build one. It's not part of class, okay? Mr. Connor is not going to require you guys to actually build an electromagnet. We would have done it in class. But because we're not in class, we're not going to build one. Okay, we're not going to build one. Just letting you guys know, be safe. Use your brain. Don't get shocked. Don't get electrocuted. Okay, that's about it on that. Okay, let's start our review now. Can you name some forces that act from a distance? You guys now know a lot more forces that act from a distance. What are some? Pasta, could you just give me one?
Gravity.
Gravity. I'll write them down for us. So we got gravity. We have gravity. Sarah, what do you think?
Magnetic force.
Magnetic force. Magnetic force. Okay, we have gravity, magnetic force. Moon, do you have any other ones? Think about rubbing a balloon on someone's hair. What is that called? What do you think, Moon? So we have gravity, magnetic force. What else do we have? What was the experiment you did at home? Did you pick up pieces of paper?
Take a piece of paper, then put a straw to make the paper select electricity.
Yeah, and what force was that? What were you using? What's that called? Do you remember? I think a classmate might be able to help you. I think a classmate will be able to help you, Moon. What is that force called? Lucky, Bunny, Sarah, Violet. What is that called?
I think it is called electromagnet.
It's not an electromagnet, but that is one of them. I will put electromagnet up here. This is also the same as a magnetic force, but we'll put electromagnet up here. What was the stuff called? So it's when you use a balloon, you pick up pieces of paper. It's called what? SCART. What's it called?
Huh?
What's the force I'm looking for? So it's the experiment you guys did at home where you picked up a piece of paper, you moved a piece of paper, you did them all these experiments at home. What was that?
Electricity.
Yeah, there you go. Static electricity. Static electricity. Static electricity. Okay, just making sure I spelled that right. It's a big word for Connor. Okay, static electricity. All right. Let's see if you guys got them. We have magnetic force, electromagnetic force. What is this one? What's the picture showing? Blue moon. What's this picture showing on the screen?
This picture,
Yeah, what's happening in the picture?
the people ocean fly.
Everything's floating up. Why do you think that? Why is everything floating?
Because
What force is no longer working? What pulls everything down to the ground, Blue Moon?
gravity.
Yeah, it's gravity. We have gravity or gravitational force, and static electricity. Okay, you guys got all of them. Good job. This is just gravity, okay? Or it's also called gravitational force. These are all the different ones you learned about forces acting from a distance. What does it mean to act from a distance? Misha, what does it mean that these forces can act from a distance. What does that mean? Act from a distance.
It means
What does it mean to act from a distance? Do these forces need to touch you? Do they need to touch you?
yes.
Yeah? Okay. Let's call in another classmate and see what they think. Mango or Sino, what do you think? What does it mean to act from a distance? Do these forces have to be touching?
The force doesn't have to be touching.
Yeah, it doesn't have to be touching. Guys, acting from a distance means the force does not have to be touching. They can act on you from a distance. They can be far, far away. The static electricity could be centimeters away from you or meters away from you and still act on you Okay. What is a magnet? What is a magnet? Let's have pasta. What's a magnet?
A magnet is something that is attracted to metal.
It attracts metal. Can you read the definition for us, pasta?
Magnets is an object that attracts things made from certain metals.
Yeah, what's a type of metal, pasta? What's one of the types of metal that it can attract?
Steel.
Yeah, steel, it has iron in it. We have steel, iron, cobalt, all that type of stuff. Okay. But we mainly humans usually work with steel and iron. Okay. What are these? What's this N and S? What is this N and S of the magnet? The N and S of the magnet. What do these stand for? Taylor, what do these stand for?
North and south.
Yeah, and they are what? North and south.
If the north face the north as well repel, and if the north face the south as well attack.
Very good. And these are poles. Yeah, these are poles. Oh. Okay, can I have Rose? Choose the word from the box that correctly completes each sentence. Rose, could you do our first sentence for us? Rose.
Money, iron, things collect near the poles
Of
a magnet.
Very good job, Rose. The poles of the magnet, the north and south pole. Okay. The farther from the magnet, the blank the filings collect. Who can read the next sentence for us? Let's have, is Jackie there? Jackie, are you there? Can you read the next sentence for everyone?
The farther from the magnet, the fewer filings collect.
Yep, the fewer the filings collect. The further away you go, the weaker the magnet gets. The further from the magnet you get, the weaker it gets. The weaker it gets. So it collects fewer filings. How far can a magnetic force act on an object? How far can a magnetic force act on an object? This is a hard one. We'll see if anyone can get it. Jack Vu, are you there? Jack Vu. How far can a magnetic force act on an object? This is a challenging one, I know. Okay, I'll call on someone else. So guys, how far can a magnetic force act on an object? It can only act on it. What's that invisible thing around it? What is that invisible thing around a magnet? The invisible thing around the magnet. Let's have SCART or emeralds. What is the invisible thing around the magnet that? How far can a magnetic force act on an object? Only as large as it's what? What goes around the magnet? What's the invisible thing around the magnet that we can see only with iron filings?
Iron filing.
No. Type me in chat if you know the answer. Type in chat if you know the answer. I'll call on you if you give me the answer in chat. Oh, I'm seeing a lot of them. Okay, Puppy got it first. Puppy.
That is magnetic field.
It is a magnetic field. As far as its magnetic field reaches. Mango, also good job. Good job, Mango. So guys, it's magnetic field. Remember, the magnetic field is invisible, but it surrounds a magnet, and that's what decides how far a force can act on an object, the magnetic force. If you get outside of the magnetic field, the magnet will no longer work. What two factors affect how many paper clips a magnet will attract? So two factors. What are two things that affect how many paper clips a magnet will attract? Okay. What two factors? What do you guys think? What can affect how many paper clips it can attract? Okay, type me in chat if you think you know one reason. What's one factor that affects how many paper clips a magnet will attract? You guys can type me in chat. If someone gets it, I will call on them. Sam, what do you think? Sam, what do you think? Let me find Sam real quick. You up here? Oh, here you are. Sam, what is one factor that might affect how many paper clips a magnet will attract? Sam?
I still can talk, but there is maybe something wrong about my screen. So
Okay.
can you say again?
Yeah. What two factors affect how many paper clips a magnet will attract? What is something that will change the amount of paper clips a magnet can attract? Are all magnets the same, or are they all the same strength, or do they come in different strengths? Or are all magnets the same? What do you think, Sam?
I think it's different.
You think they're different? Okay, why? What makes a different? What makes one magnet different from the other? What are some things that can make them different? What can make one stronger than the other?
Like kinds of magnets.
The kind of magnet, yeah. There's different kinds of magnets. Some magnets are made out of different types of metal, okay? And they're stronger or weaker, okay? Thank you, Sam. What else?
Even one magnet can be different from it when you put it further.
Yeah, the distance, right? A distance is one of the factors. What two factors affect how many paper clips a magnet will attract? You could put them at a further distance. Does it attract fewer or more paper clips, Sam, at a distance, a further distance? Will the magnet, did you already mute? Sophia, will a magnet attract fewer or more paper clips, the further away you get. The further away you get.
So fewer.
Fewer. Very good. And Sophia, could you read the answer on the board? I'll put the answer up.
The strength of the magnet and the distance between the object and the magnet.
Yeah, so guys, those are the two factors. How strong the magnet is and how far away the magnet is. Those are the two factors. The two factors. I will underline them. So we have two factors. Two factors, and that is the strength of the magnet and the distance between the object and the magnet. So the strength and the distance. These are the two factors. These are the two factors. One factor, two. Okay, let's keep on going. Okay, I would like you guys to circle what might be attracted to our magnet. Circle what you think might be attracted to this magnet. Make sure you guys just draw one circle. Everyone can circle in 3, 2, 1, go. Circle what you think might be attracted to our magnet. Good job, Sarah, Lucky, Bunny, Mango, Sophia, Kim, Rose, Alex, Emma. Good job. Lisa, good job. Okay, Kim, let's not draw randomly, please. Let's not draw randomly, Kim. Kim, please. Pasta. Guys, come on. Okay, so you guys got it correct. You guys circled the knife and the metal spoon. Let's test it out.
And
The knife and metal spoon. Banana, please stop requesting control. Banana, please stop requesting control.
and the magnet too. It can stick to each other.
Yeah, they can stick to each other. But the knife and metal spoon are what are attracted to our magnet. A marble is made out of glass. Is glass attracted to a magnet? Banana, is glass attracted to a magnet? Banana? Attracted to a magnet. Is glass attracted to a magnet? Would a marble be attracted to a magnet?
Yes.
Yes, glass would be. What's the one thing that's attracted to a magnet? What's the one thing that's attracted to a magnet?
Metal.
Metals. Is marbles made out of metal? No. No, magnets are marbles are made out of glass. So they would not be attracted. Okay. So we're gonna try to make, what is this called? What is this called? Who can remind me, what is this called? Who remembers the name of this? Raise your hand in your video if you remember. Sam, what do you think it is? Sam, what is it?
I think it is a diagram.
Yeah, it's a diagram. It's called a Venn diagram. Okay. So we're gonna, on the left, we're gonna put things that belong in electricity. This includes, okay. Guys, you can also, this could also be static electricity. That is included in this, okay? This is included in this, okay? Static electricity is also included in this, okay? So electricity or static electricity and magnetism. A word is gonna come up on the screen. A word is gonna come up on the screen and we have to decide if it's for static electricity and electricity, magnetism, or both, So we have to decide, okay? Let's get started. So our first word is repels other magnets. Moon, what do you think this is? Is this magnetism or electricity? Repels other magnets.
I think it's magnetism.
You think it's magnetism? Okay, I'm gonna click the button. Let's see. You are correct. It moved over to magnetism. Good job. Let's have Lisa. Our next word is opposites attract. Opposites attract. Is this electricity, magnetism, or both? Opposites attract. Is this electricity, magnetism, or both? What do you think?
Magnetism.
Magnetism. Okay, we'll check it. We're gonna check it. Oh, it was both. Both static electricity and magnetism's opposite attract. Remember, electricity is positive and negative. Magnetism is north and south. North and south. Electricity is positive and negative. Magnetism is north and south, but the opposites attract. Our next word, it powers things. Ray, where does this go? It powers things.
Our things goes to electricity.
Electricity, let's move it over there. Boom. Okay, it powers things got moved. Let's have distance matters. Distance matters. Kim, for which one does distance matter? Electricity, magnetism, or both?
Um,
Do you think it's just electricity, just magnetism, or do you think both of them distance matters? What do you think?
I think
Let's see if we'll have a classmate help you. We'll have a classmate. Emma, what do you think?
distance
Emma, what do you
magnet.
think?
No.
Magnetism?
Magnetism.
Okay, magnetism. Okay, I'm gonna call one more person, just one more person. Bunny, what do you think? Bunny, Funny, Sunny. What do you think, Sunny?
I think both.
Both. Yeah, I think so too. Let's see. Oh, it is both. It is both. Bunny got it. Bunny got it. Good job, Bunny. Guys, so distance matter is going to matter for both electricity and magnetism. Think about when you rubbed your balloon. Think about when you rubbed your balloon or did your experiment. You had to get close enough for it to work. You had to get close enough for it to work. Okay, our next word, positive and negative. Positive and negative. Let's have Alex. Where does positive and negative go?
Go electricity.
Electricity, exactly. Electricity are positive and negative. Our next word, attracts other magnets. Attracts other magnets. Sophia, attracts other magnets. Does this go for electricity, magnetism, or both? Attracts other magnets.
I think it is both.
You think it is both? Okay. Let's see what another classmate thinks. Banana, what do you think? Attracts other magnets. Does this go under electricity, magnetism, or both?
Magnet.
Magnet, okay. And then we'll call on one more person to check. One of you are correct. One of you is correct. Lisa, where does it go? Attracts other magnets. Is this electricity, magnetism, or both? Look at the Venn diagram so far. There's clues in the Venn diagram. Electricity has, it powers things, positive / negative. Both has distance matters and opposites attract. And then magnetism has repels other magnets. So what do you think? Where do you think attracts other magnets goes?
Magnetism.
Magnetism. Good job, Lisa. Good job. You got it. You guys got it so far. You guys are doing good. Okay, our next word. North and south. North and south. Misha, where do you think this goes? Misha, where do you think this goes?
Yeah. Yes.
Where does the word north and south go? Electricity, both, or magnetism?
Can you say it again?
Yeah, we're looking at the word north and south. North and south. Where does this word belong? Under electricity, magnetism, or both? Which word? Electricity, both, or magnetism? What has north and south? Okay, we're gonna get a good classmate to help you, Misha. What's your guess though? Misha, just guess one. What's your guess?
I guess is it both?
Both. Okay, that's your guess. Both. Okay. Cherry, what do you think it is?
Can you say again?
What? Okay, where do you think the word north and south go? The words north and south. Electricity, both, or magnetism? Where do the words north and south go? Guys, think about north and south pole. North and south pole. What has a north and south pole? Guys, this one is not too hard. Type me in chat if you know what it is. Type me in chat. Pasta, what is it? Pasta. Good job, Lucky. Good job, Kim. Pasta, what is it? Let me allow that you guys on mute. Pasta, what is it?
No, magnetism.
It's magnetism, guys. North and south poles. North and south poles is magnetism. Okay, Pasta, do you want to do one? What is voltage? Voltage, Pasta.
Electricity.
Electricity, that is voltage. That is voltage. Okay. And then our final word is creates a pole. Creates a pole. Is this electricity, both, or magnetism? Is able to pull on things. Pasta got it correct. Zook. Zook, where does this go? Under electricity, magnetism, or both? Is able to pull on things. Creates a pull.
Magnetism.
Magnetism definitely is right. Magnetism is right. But what else is right? Does static electricity pull on things? On the pieces of paper?
Yes.
Yeah, so
Both.
it's what?
Both.
Both.
Both. Both.
Yep. Both. Complete. Good job. Zook completed it. Good job, guys. You guys finished your Venn diagram. For electricity, we have it powers things. Voltage, positive and negative. For magnetism, we have north and south. Attracts other magnets, repels other magnets. And then for both, the distance matters, opposites attract, and creates a pull. Okay. Now that is it for today. What your homework is to do the lesson check. Did not mean to draw. Your homework is to do the lesson check and lesson roundup and the lesson roundup, okay? Page 129, 127 to 129. Circle them now. 127.